Hello, this is question 11 from the step 3 paper in 2022. This is the first of the stats questions. So we've got a fair coin tossed n times and the random variable x records the number of heads. The mean deviation delta of x is defined by delta is the expected value of the modulus of x minus mu, where mu is the mean of x. Okay. Let n, capital N, be 2 lowercase n, where n is a positive integer, right? So we've got n, we've got an even number of coin tosses is what we've got going on there. So we have to show that the probability of x being less than or equal to n minus 1 is equal to that thing. Right, okay, so this is going to be playing off the fact that we've got a fair coin. So we've got, well, binomial distribution because it's a coin, so we've got 2 outcomes each time. And then a fair coin means we've got a symmetrical binomial distribution. So you might have seen this sort of thing before. I mean, you don't need to have seen it in order to answer the question, but it's playing on the fact, you know, where this half is coming in here is playing on the fact that whether we're looking at heads or tails doesn't really make any difference in this. We've got the same probability of each outcome. So if we've got some kind of distribution, then what we're looking at on the left of the distribution is the same as what we're looking at on the right of the distribution. So in other words, we can say that the probability of x being less than or equal to n minus 1 is going to be equal to the probability of x being greater than or equal to n plus 1. And we can set it up this way again because they've gone for an even number of coin tosses. So if we've got an even number of coin tosses, we've got an odd number of possible outcomes. So say we did 4 coin tosses, you could get 0, 1, 2, 3 or 4 heads. So for 4 events, we've got 5 possible outcomes here in terms of the number of heads that we're actually going to be tossing when we flip the coin. So we can have this set here, the 0 and the 1, which is going to have exactly the same probability as the 3 and the 4. And then we've got the number in the middle. So that's what we've got with these. Right, so where was I on all of this? So yeah, I need to show that this thing holds then. So we've got the probability that we're getting x being less than equal to n minus 1, plus the probability that we're getting x is equal to n, plus the probability that x is greater than equal to n plus 1, as in all of the options, all possible outcomes. So the sum of those possibilities have got to be 1. And now we're just combining these two things to get what we're showing in, in the answer here. So as I say, you might have seen this sort of thing before. So we've now got then that 2 lots of the probability of x being less than or equal to n minus 1 is going to be 1 minus the probability of x being equal to n. And now we're just halving everything. And then we've got the answer that we want. Right, so that's warmed us up, and it's got us in the mindset, I suppose, that we are looking at a symmetrical binomial distribution here. So push on to part B. We now have to show this. So we are actually now going to calculate this expected value here. And they're going from r is 0 up to n minus 1. Right, okay. So we're going to, well, let's go through our standard way of calculating these values then. So delta, expected value of the modulus of x minus mu, is going to be equal to, so we want to sum up over all of our possibilities. So we can go, r is going from 0 up to 2 lowercase n. So that's all of our possible outcomes that we've got here. Then we've got the thing that we're evaluating. So in this case, our x is now the r. And we've got a minus mu. You see, you've got no mu in the answer. But we know that mu is, and I'll put this down here, where mu is equal to lowercase n. This is by symmetry because we've got this symmetrical distribution again. So if we've got a perfectly fair coin which is being tossed an even number of times, then mu, our mean, is going to be, well, it's going to be this number in the middle. It's going to be 2. That's what we're going to be getting for the mean. So our mu is going to be equal to lowercase n in this case. So we can replace that in there. And then we need to multiply each one of these outcomes, by the probability of that outcome. So we've got the choose number, so we'll have a 2n choose r going in there, and then we'll have the probability of getting that number of heads multiplied by the probability of getting that number of tails, so that'll be a 2n minus r. So we have to evaluate this. So we got a lot of things in place already. I mean, all of those halves there aren't far off this. We need to chop the upper limit of our sum down a bit, and we need to get rid of the modulus. So getting rid of the modulus suggests splitting the sum into 2 bits, one where the modulus takes effect and one where it doesn't. So the modulus will take effect up until, well, I mean, we could go up, so let's go up to n minus 1. I mean, that's going to be, as soon as r hits n, then, well, actually, when r hits n, we get a 0 out of it, so we can just ignore that one completely. But for r is 0 up to n minus 1, the modulus is taking effect, so we'll just flip that around and put it in brackets. And then we've got all the rest of it. I'll combine those halves. That would just be a half to the 2n. And then, well, as I've just said, the n doesn't actually come into it, so we can drop that one and go to our next. That'll go up to n plus 1 for the next sum, all the way up to 2n. And then this time the modulus doesn't matter, so we just remove it. And then we've got that. And then we've got half to the 2n again. Right, so we're in a reasonable looking position here. So in fact, the first sum is almost the answer. We've just got a factor of 2 thrown in. So really we're saying that, assuming I've got it right so far, that these two sums are the same, in which case the answer will drop out. So all attention is on second sum then. So see how I can turn these. I mean, the limits are the most interesting part of this. I need to flip these limits around. So that is going to fit in again, isn't it, with this being a symmetrical function. So whether I'm starting from the left or whether I'm starting from the right, I'm getting the same result. So it should be then, so if I can rewrite this and say, okay, that's starting at 0 and then that's going to n minus 1, then all of the rest of it should sort of unravel to look the same as the first part, because our choose numbers are going to be the same, whether we're starting on the left or on the right of our row of Pascal's triangle. It doesn't make any difference which end, the whole thing's symmetrical. So, and hopefully this bracket is going to unravel in the middle. So I need to, so say I wasn't going with R anymore. Let's say I was, well, next letter along, S. So I want S to be equal to 0 when R is 2n. I want S to be equal to n minus 1 when R is n plus 1. So S is going to be, well, it's either 2n minus R or R minus 2n. Which way round is it going to be? So, because that works for the first one. So if I was doing 2n minus R, then I'd get 2n minus n minus 1. So that works. So S is 2n minus R. So let's put that in to here. So let's say, let S equal 2n minus R. And now this sum then is going to be, so I've got the sum S, well, the limits, I mean, I could put 0 at the top and n minus 1 at the bottom. That would be kind of unconventional. So I'll put the 0 at the top and the n minus 1 at the top. It doesn't matter. 0 at the bottom, I mean, and the n minus 1 at the top. It doesn't matter which order you have, sum everything up, but that's more conventional, isn't it? So in the bracket then, I've got that R is 2n minus S. So I've got 2n minus n minus S. That's right, isn't it? 2n minus S. Yeah, so I'll have an n minus S. And then here I've now got 2n and R is 2n minus S. And then I've still got the half to the 2n. Right, so this is the same as the other one, isn't it? Because, so let's do a where. The choose numbers, again, it doesn't matter which end you start at. So 2n choose R is equal to 2n choose 2n minus S. Well, I should put R in, not S. So R minus R. So they're the same. So therefore, these two sums are the same as each other. I don't really have much space to write that out, but the only difference is I've got S's written in rather than R's written in, but we can just sub them over. I've changed everything now so that they look the same as each other. So, right, so therefore, let's just section that bit off a bit. I've got that delta is equal to 2 lots of the sum from R equals 0 to n minus 1 of n minus R, 2n choose R, and then 1, well, a half to the 2n, which is then the answer. So they've just got that factor of 2, which has then changed that to from a 2n on the bottom to a 2n minus 1. So there we go. Right, so that's done part B. That was pretty involved. Now let's go on to a new sheet. Part C, show that for R is greater than 0, we've got these things are the same as each other. Okay, right, well, I suppose we just got to plug them into the definition. So that is going to be R, well, I don't know why I did a bracket that big, because I'm going to have a fraction here, so let's do a smaller bracket. So 2n factorial divided by, then I'll have to have R factorial and 2n minus R factorial. So is that obviously going to be the same as that? Not really, no. So let's see, what have we got? They've taken a 2n out, so I could say 2n times 2n minus 1 factorial, and then I've got an R over this R factorial, so that's going to get rid of, well, the last R in it, so that's going to be an R minus 1 factorial. Okay, it's getting closer to what I want. So the bit at the bottom, then they must have written this in a weird way. So this is going to have to be a 2n minus 1 and then minus R minus 1 factorial. Does that work? So 2n minus 1, I'm then going to add an R, so that'll get rid of, not add an R, add a 1, which will get rid of that 1, and I'm going to take an R off, yeah, which is the same. So which is equal to 2n minus 1, choose R minus 1. Right. Does that all follow through? I've done, so yeah, that does seem to follow through. It's taken up a lot of space for what it is. Maybe getting a bit carried away with the old handwriting there, but anyway. Yeah, I'll do a new sheet then for the last part, although hopefully this will be quite quick because it's the second part of the question. So hence show. So we're just combining what we've shown there with what we've shown here. Right. So how am I going to go about doing that then? I've got a, so this is the thing that I'm replacing here, that bit. I've got an R times 2n choose R. And that's not a lot to replace though, is it? I mean, it ain't just going to drop out off of that. No, I mean, it suggests putting it as 2 separate sums again. You know, I can split, I can expand out the bracket and do 2 sums. I'm hoping that was just going to like fall out, but it's not, is it? So okay, well, let's try doing then, let's write it as 2 sums. So I'm going to have the sum from R equals 0 to n minus 1 of n 2n choose R 1 over 2 to the 2n minus 1, and then I need to take off the sum from R equals 0 to n minus 1, and then I've got an R, I can sub in this thing now, so 2n minus 1 R minus 1, and then I've got that thing going on again. Okay, well, that doesn't strike me as being something that's going to be obvious what to do. I mean, I've got all these n's I can take outside, so I'm just summing up choose numbers. Doesn't seem to be what it is, doesn't it, on all of this, because I don't have any r's kicking around, so it is just summing up choose numbers. So let's take these one at a time then. So let's take that one. So if I was doing the sum, but we're not going all the way to the end, I'm not going all the way to the end, then how am I going to sum up these? Right, anyway, let's say I was going all the way to the end. Let's get a the sum from r is 0 to, well, we've got 2n options here of all of those choose numbers is going to be 2 to the 2n. I mean, that's what we get for a binomial distribution. So we've got that, and that is going to be equal to, so I've got the sum from r is 0 to n minus 1. But that's also going to be the same for that same number of terms, for n terms on the other side as well. So as in, if I do that and then I add on r is n plus 1 to 2n, so they've got the same number of terms, those things are the same as each other, because it doesn't matter on our Pascal's triangle which end we start. If we start from the left or the right, these things are symmetrical, but I don't have the term in the middle, which is my 2nn. Right, so at least that's shown up, because I need that in the answer. So what does that mean then for this first sum? So this first sum then, I've got, so the sum from r is 0 to n minus 1 of n 2n choose r 1 over 2 to the 2n minus 1 is going to be equal to, I've got to do 2 to the 2n minus 2n choose n, and then I need to do a half of this. Okay, I think that is everything, isn't it? Yep, that looks like it's everything. Okay, right, so I've got that, and now I need to deal with the second sum. So is this going to be same on this? That, oh, I've already got a problem on the second sum. So I've just noticed this. So I couldn't do that substitution. Right, that's a blow, isn't it? That is a blow. So I couldn't do that. That only works for r is greater than 0. So I'm going to have to change that to a 1, but then what am I left with? What was the bit that I missed out? So that would have been, okay, right, so I'm going to have to change that to a 1. And then I also need to take off, just going to have one value for r, oh, it's going to be nothing anyway. Okay, minus 0 for r equals 0. Because, yeah, we just got r times something. Okay, we just got a factor of r in there. Right, okay, that's, God, I have been worried for a minute. Right, but that's okay to make that substitution, but it has caused a problem of now I'm not doing exactly the same thing for summing up these choose numbers, because I'm starting at 1 for r, I'm not starting at 0. Right, so anyway, let's write out what I'm trying to do then. So I want to do the sum from r, I'll do the whole lot. I'm trying to replicate this as much as possible. So r is 0 up to, but now I've got 2n minus 1 terms of 2n minus 1 r. So that is 2 to the 2n minus 1. So I've got that. Now I've got a bit going from r is 1 up to n minus 1. Oh, actually, I think I've just chanced upon the way of doing it by copying this and putting it there. I can now see what I need to do with this. I just need to drop it down, don't I? If I change it, because I'm knocking 1 off r anyway. So I can bring that limit down to 0 at the bottom and take the 1 off the, right, that was a bit of a lucky I wasn't thinking that way until I copied this and it solved my problem with that. Right, okay, that was a result. So what am I doing? What am I saying with this? I'm saying that this thing is essentially, I'm going to make that back to a 0 and get rid of that, which would make that a minus 2. So I'm dropping all my r values down 1 on the sum, which means I don't have to drop them down by 1 inside the sum. Right, that's good. That is good. So where was I? Down here. I've got r is 0 is that thing. Right, okay, so now I'm doing the rest of this bit. So I need to go, I'm interested in r is 0 up to n minus 2 of 2n minus 1 choose r. So at the other end of it then, so if I was going to have 2 of those, I'm going to be going from, so I want to have n minus 1 terms. So I'm going to have the, this one isn't going to be included. I'm going to have a 2n minus 1, n minus 1. And then I can have another one. I'm trying to think here. So if I'm going from, let's do a little note here. So I'm going from 0 to n minus 2. At the other end, I'll be going from 2n minus 1 down to, and I want to have n minus 1 terms. So if I had n plus 1, so n minus 2 minus 0 is n minus 2, n minus 2n minus 1 minus n plus 1 is n minus 2. So yes, so that means I do need to have 2n minus 1 choose n in there, and then I get to the n minus 1, n plus 1 to 2n minus 1 will have the same number of terms, and it will be the same as the sum that I'm trying to work out. Excellent. Right, so what's that meaning then? What does that mean? So I've now got then the thing that I want, my sum. So my sum from r is 0 to n minus 2 of 2n minus 1 choose r. So that's the thing that I'm after up here, is going to be equal to 2 to the 2n minus 1 minus both of these things. So it's a bit annoying that I've got two of these kicking around. One of them would have been nicer. But these are going to be the same as each other as well, aren't they? Because I'm splitting everything 50-50 here. We don't have a middle number on this one because we got 2n minus 1. So I'm going from 0 to n minus 2 gives me this great big block in the sum there, which is the same as the block on the other side of the distribution. And then I've left two values in the middle, which must be the same as each other. So I can take off two lots of one of these. So 2n minus 1 choose, well, n's closer to the answer. So let's go with that. But it doesn't really matter which one I pick. I could take either one of them because they're identical to each other. So I've got that. And then what do I have to do? I have to halve it. So I've got half of that. So now let's go back to blue then. Delta might just drop out. Well, I don't know about drop out. This with the amount of work this has taken. But delta should be the combination of all of this stuff. So what have I got? I've got, and what have I got? I've got this thing here. So I've got an n over 2 to the 2n minus 1. And then I've got my sum for this one. Yeah. Oh, I've not written these bits in this. So that would be an n 1 over 2 to the 2n minus 1. So I've got that, but now I need to multiply by a half of 2 to the 2n minus 2n choose n. Okay, so that's one bit. And then I need to take off, God, this is all over the place as well. So this is my sum here. But what did I've got a 2n this time, 2n over 2 to the 2n minus 1, multiplied by a half of 2 to the 2n minus 1 minus 2 lots of 2n minus 1 choose n. Wow. Okay. Well, that 2 cancels with that half, so that helps. I've got the same factor here. So let's put these together. See what I'm going to end up getting. So n over 2 to the 2n minus 1, and then I've got a half of 2 to the 2n, so that is 2 to the 2n minus 1, minus 2n choose n, minus 2 to the 2n minus 1, right, so that's cancelled, and then plus 2 lots, 2n minus 1 choose n. Right, so I've nearly got the answer, but I haven't got the answer. So how's that going to work then? How am I going to get the last bit and all of this? So I must have, I mean, those things have gone away. I need to get an extra half in here somewhere, don't I? So, well, let's get a relationship. Clearly, I've got to have a relationship between these choose values here. And I want to end up with a 2n choose n. So let's have a closer look at these. God, I'm really running out of screen here. Let's do a bit of, so 2n minus 1 choose n. So that is going to be 2n minus 1 factorial over n factorial, and then n minus 1 factorial. Okay, and I want to turn this into something to do with 2 to the n factorial over n factorial n factorial. Right, so I'm going to need to multiply the bottom by, well, top and bottom by an n is certainly going to help on this one. So if I put an n and an n top and bottom, then that deals with the denominator. And then I'm still short of, I need to multiply by 2n over 2n. Yeah, we go, that'll work. Right, so that is equal, yeah, so 2n times 2n minus 1 factorial over 2n, 2n, I missed out the n factorial bit, 2n times n factorial, 2n minus 1 factorial. Right, so yes, so this will make the 2n, oh no, that's just an n minus 1 in there actually, isn't it? So what am I doing? What am I doing? Yeah, so the 2n multiplied by the 2n minus 1 factorial gives me a 2n factorial. The n times the n minus 1 factorial gives me an n factorial. So I've got half of it, all in all. So, right, so this thing is equal to a half of that. So I've now got everything is cancelled out, which means I've got 0 as an answer. So what have I done wrong? I must have lost a 2 somewhere out of all of this. So where have I gone wrong? Because, yeah, that's come out as half of this. So, right, tracing backwards. Oh, here we go. I've not put a half in there. There we go. So that is going to be equal to then n over 2 to the 2n minus 1. And then I've got a half of 2n choose n. Right, which is the answer, yeah, because that 2 there is going to get rid of that there. So there we go, tick. Wow, that was ridiculously complicated. And I really did have to squeeze this little bit. It's not ideal fitting on this screen again, but you can see what I did with the choose numbers, hopefully. Just getting that relationship between the 2n minus 1 choose n and the 2n choose n. So, yeah, that was hefty, to say the least. Right, I've got one part left then. Find a similar expression for delta in the case that n, capital N, is 2n plus 1. Right, so we've gone over to an odd setup then. So we've got to do it all again. Oh, this is one where it'd be really nice to have this all on the screen so I can just see what I've done and then redo it all. So we've now got n is this. So our mu has changed then. So mu now is going to be 2n plus 1 over 2. So this is our new mu. And we're having to do, well, the same setup as we had before. Right, I think what I'm going to do with this, because it's going to take me a lot of messing around trying to, duplicate the previous process, is I'm going to pause the tape, pause the recorder, and write out what I've put on the previous screen so I can look at it while I'm doing this part of the question. And then it means I should be able to flow through a bit quicker than I would do if flicking backwards and forwards between screens. Right, so we're back doing the same again. This is the same as the last part of the question, except now we've got an odd number of coin tosses, so we've got an even number of outcomes. So this is going to make a change to things, but let's just try copying more or less what I did before. So this is now the sum from r is 0 again. Now we've got 2n plus 1 at the top of our sum. We've still got the mod of r minus mu, so 2n plus 1 over 2. And then we've got our choose number is now 2n plus 1, choose r. And then we've got a half to 2n plus 1. So we have to do exactly the same steps before. Now, how is this gonna, this might split a bit easier, mightn't it, on this? Because we've got, is this going to work? So yeah, if we're going from 0 to 2n plus 1, so we've now got 2n plus 2 options. So they're exactly split in half. So we don't have like a middle value now. We've got what's on the left and what's on the right, and these things are the same as each other. So that is going to be exactly the same as 2 lots of the sum of r is 0 up to n. So that's n plus 1 outcomes. And then if we're going from r is 0 up to n, then the modulus does take effect. So we can do a 2n plus 1 over 2 minus r. And then 2n plus 1 choose r. And then a half to the 2 to the n plus 1. Okay, so that's good. Which means I can get rid of that 2 and that 1. So that's even better. So I'm just doing that. Again, I need to split this into the two sums and use this thing because that's what we did last time. So that is going to be equal to, let's take the half to the 2n out front. And then I'm going to have then a sum of 2n plus 1 over 2 times this sum. So r is 0 to n of these choose numbers, 2n plus 1 choose r. Then I need to take off the sum from r is 0 to n of, now I'm doing this substitution. So 2n has now become 2n plus 1. So I've got 2n plus 1. And so I've got factors of 2n plus 1 kicking around all over the place, which is nice. And then this choose number is going to be 2n plus 1 minus 1, gives me a 2n. And then I'll have an r minus 1, which I've moved up by dropping the limit down, just as we did before. Right, so that's good. So I can, these 2n plus 1s are going to factorize quite nicely. So I've got to do the sum of these, this one here is just going to be 2 to the 2n plus 1 over 2. So that's all of the choose numbers added up, and then I'm halving them just because it's now split neatly into two halves. And then this one isn't going to be as neat though, is it? This one is going to split into, I'm going to have 2 to the 2n, but I am going to have a middle number. So I'm going to need to take off the 2n choose n, and then I'm going to have half of that. Right, okay. So when I put those together, factorize the 2n plus 1. So I've got 2n plus 1 over 2 to the 2n. Then what have I got? I've got a half of this thing. So, well, that's just cancelling with that for a starter. So I don't have to worry about that. And now I've got a half of it because I've still got that 2 there. So that's 2 to the 2n minus 1. And then I need to take off 2 to the 2n minus 1. So that's good. And then I need to add on a half of 2n choose n. Right. So that is, so they've cancelled. So I've got 2n plus 1 over 2 to the 2n plus 1. So I've got lots of 2n plus 1s around. 2n choose n. Right, that's great. I mean, that dropped out a lot quicker than the previous part of the question because we've done it all once before. I would say that was, well, for me anyway, I mean, stats aren't my favourite questions. I would have said that was particularly difficult as questions go. There's no way I would have touched this with a barge pole if I was doing the actual test. The part A was fine. B wasn't particularly easy, but it was sort of manageable. C started off, the first bit was really easy, which sort of lulled into a false sense of security about the horrendousness that then came up working out this delta. And then the last part was fine. But the last part was fine only if you'd gone through the agony of part C. If you hadn't done, then you haven't just got a result there that you can use in order to do the last part of the question. So it's sort of all or nothing on that. but I would imagine that was not a popular question in this particular paper, but at least it's got one of the stats ones out of the way. So only one more to go to finish off the paper. Yeah, just popping back to add this little postscript onto this video, because I watched this back because it was a particularly difficult question, so I thought I'd watch it through again. Noticed I missed the -1 off of there, so I thought I'd come back just to add that in for completeness.